Hello students. Now we'll discuss the topic, very important topic in states of matter, that is in liquid state, that vapor pressure of liquid. We know liquid has different characteristics, different properties. Liquid can flow. Liquid has definite volume but no definite shape. Liquid has boiling point, already know it boils at particular temperature. Liquid evaporates. So many characteristics liquid possesses, and liquid state is the intermediate state of the matter. So you can convert liquid to solid or liquid to gas under different specific temperature. By using energy, by heat, you can convert liquid to gas or vapors. If you decrease the temperature, you can convert liquid to solid. So the physical state of matter can be changed by changing temperature and pressure. So today we will discuss some important properties of liquid, that is vapor pressure. So we know that if liquid will be kept in a liquid kept in this closed container. It is closed by a stopcock. It is closed. Taking liquid. But we know that liquid evaporates. The evaporation of liquid generally takes place at room temperature also. So when liquid evaporates, then it is converted to vapors. So this stage is called evaporation. This is called evaporation. Conversion of liquid to vapors. It always takes place at room temperature also it takes place. There is no fixed temperature evaporation takes place. Evaporation takes place at every temperature. So liquid when we kept in a closed container, then it converts to vapor. So vapors will be increased with time. So number of vapors molecule will be more on the surface of liquid. Then when the number of vapors will be increased at the surface of liquid, then we know the properties of gas, properties of vapor, as they are free to move. When their concentration, when the number of vapor molecules will be more on the surface of liquid, then it is returned back. This vapor again return back to the liquid state. This is called condensation. So this evaporation and condensation takes place because the vessel is kept closed. As it is kept closed, so vapor cannot go outside. So on the surface of liquid, the concentration of vapor will be more. Then the number of vapors molecules same time come to the liquid. It will again added in the liquid. So evaporation and condensation occurs side by side. Both takes place. Some liquid molecule convert to vapors. Again some vapor molecule convert to liquid state. So a stage will come when liquid convert to vapor. This is called your evaporation. This is called evaporation. At same time, vapor again condenses to liquid. This is called condensation. When the stage will come, both liquid and vapor will achieve equilibrium. When it will remain in equilibrium. Equilibrium means evaporation and condensation. Evaporation, condensation, when it takes place simultaneously, the rate of evaporation, number of liquid molecule convert vapors, at the same time number of vapor molecule convert to liquid, because the vessel is kept open, so vapor cannot go outside. This thing you will observe physically, so that at the surface of liquid, at the upper part of the vessel of the liquid, some liquid will be droplets, liquid droplets will stick on the wall of the container. That is indicates that evaporation is going on. So evaporation and condensation when occurs simultaneously, when the rate of evaporation and condensation will equal, that is called equilibrium, state of equilibrium. That is called state of equilibrium. This is state, is called state of equilibrium. At this stage, at this condition, when you measure the vapor of the liquid during this condition at the equilibrium state, this pressure is called the pressure given by a vapor of liquid at this condition, not initially. When the equilibrium will be achieved, when you measure the pressure of vapor of liquid at this condition, at this temperature, that is called vapor pressure liquid. So what is vapor pressure liquid? Vapor pressure of liquid. What is this? Vapor pressure liquid. It is the pressure of the vapor of liquid, at the equilibrium state, at constant temperature. Temperature should be constant. We should not change it. At any temperature you can measure the vapor pressure, but the vapor pressure will change. But at a particular temperature, when you measure the vapor pressure liquid, you have to take the liquid in a closed container, then you observe some time, you wait some time, when the pressure of the vapor of liquid will remain constant at the same temperature. With time, if you keep more time, you maintain constant temperature. If the vapor pressure remaining constant, that indicates liquid and vapor are in equilibrium. At this condition, if you fit the barometer, when you fit with the barometer, when you feed the container with barometer, then, sorry, not barometer, manometer. When you contain the vessel, when you fix this vessel with manometer, then when you fix with manometer, then it gives the reading. That reading obtained from manometer is the vapor pressure of the liquid at this temperature. So vapor pressure liquid is the pressure of the vapor of liquid at the equilibrium state. This is very important. What do you mean by equilibrium state? The state in which liquid and vapors are in equilibrium. That means the rate of evaporation is equal to rate of condensation. At this stage, when you measure the pressure of the vapor of liquid, that is called what? Vapor pressure. Then vapor pressure, all liquid has vapor pressure. Liquid has some fixed vapor pressure at a particular temperature. For the particular liquid, at the same temperature, vapor pressure is constant. When you take the pure liquid, but liquid vapor pressure, the vapor pressure liquid can be changed, can be affected. So what are the unit of vapor pressure? It is measured, vapor pressure liquid, it is measured by the unit of pressure. Unit of pressure. We know unit of pressure is atm, millimeter, torr, bar. So many units we are measuring the unit of pressure. So vapor pressure unit is same as the pressure unit. But it depends mainly what the particular temperature, at what temperature you are measuring the vapor pressure. That is very important. And it should be measured in a closed container when the liquid and vapors attaining the equilibrium. So what are the factors affecting vapor pressure? Factors affecting vapor pressure. Very important factors. That first one is nature of liquid. Nature of liquid. We know different liquids that intermolecular force are different. Some are highly volatile like spirit. Some are very viscous, honey, glycerin. These are liquid, but they are more high denser liquid. High denser liquid means high viscosity. So nature of liquid also very important. Which liquid is free to move? Which liquid the particles are very free? So it depends upon nature of liquid. If molecule's intermolecular force is very weak, then molecule can easily convert to vapors. So first is vapor pressure is inversely proportional to intermolecular force. Intermolecular force. Intermolecular force means if intermolecular force is more, then vapor pressure will be less. Example, you can give the example. Example, suppose glycerin has low vapor pressure compared to honey, less than your water. You see, glycerin, honey and water like this. So if the intermolecular force is more, then the vapor pressure will be less. So glycerin, honey, water, then spirit, alcohol, like this. Then you can say like this: alcohol, then acetone, then ether, like this. So these are some the intermolecular force. If you see intermolecular force of ether is very low intermolecular force. So what happens? High vapor pressure. Then acetone, then alcohol, then water, then honey, glycerin, like this. So more intermolecular force, lower will be the vapor pressure. So natural liquid also affect the vapor pressure of the liquid. The second one is temperature. Vapor pressure is directly proportional to temperature. When we are measuring the vapor pressure of liquid, the temperature should be constant. When we are measuring a particular temperature, vapor pressure of pure liquid remain constant. If you increase the temperature, the number of vapors will be more. At the surface, number of vapor will be more, then vapor pressure, automatically pressure will be more. If vapors are more, then pressure will be more. That's why vapor pressure is directly proportional to temperature. You can draw the graph. Suppose the graph will be like, suppose this is the graph, this is your vapor pressure, this is the temperature. If already know the liquid evaporates at room temperature, so you can start the graph like this. Like this. So this is, if you see this second one, this is second one, this is first one. So second one has higher vapor pressure than first one, because what? This liquid is more volatile than first one. But for both cases, by increasing temperature, the vapor pressure increases. You see the graph. Both are straight line. But why you are starting from this is origin? Why you are starting above the origin? Because the liquid has some vapor pressure from the beginning. That means at some temperature. At particular temperature, it has already some vapor pressure. That's why we are starting the graph from above the origin. That is not from zero. Above the zero, we are starting. So, vapor pressure is directly proportional to temperature. This is a very important thing. Then third one is, if you are non-volatile solid, if you are non-volatile solute like salt, sugar, like this. Example is salt, sugar. If you are, it is non-volatile, then it decreases the vapor pressure. Non-volatile solute decreases the vapor pressure. Is very important. Any non-volatile, if you add salt to water, vapor pressure of water decreases. Why? Why non-volatile solute decrease the vapor pressure? Because when you add the solute or non-volatile solute, the non-volatile solute takes some space on the surface of liquid. When it takes some area, some space on the liquid, that's why the average kinetic energy of liquid decreases. When you add some non-volatile solute to the water, the average kinetic energy of liquid decreases because the space is occupied by non-volatile components. When the non-volatile components occupies, suppose one thing, suppose you are sitting in the room. If others are coming, they are occupying your place. So your performance will be, if you see, your performance may be decreased. They are interfering. If they are interfering, suppose you are running inside the room. Suppose you are moving fastly, running inside the room. If somebody enter and obstruct you, then your movement will be restricted. So your the velocity, average velocity will be decreased. Similarly, when the non-volatile solute added in the liquid, then these non-volatile solute molecules that occupies in the space of water molecule. That's why the average kinetic energy, the movement, free movement of water molecule, solvent molecule decreases. That's why kinetic energy decreases. When kinetic energy decreases, then automatically vapor pressure will be low. So when non-volatile solute added, it decreases the vapor pressure of liquid. This is very important. That's why salt solution has low vapor pressure than water. Salt solution has a lower vapor pressure than water. If you calculate the vapor pressure of water, then by adding salt to water, then salt water has a lower vapor pressure. So this is very important thing that what? But if you are volatile component, then vapor pressure will be more. Vapor pressure of the particular liquid will be more. That means that vapor pressure we got before adding volatile component, after adding the vapor pressure will be more, because the volatile component itself giving vapor pressure, because it is volatile. The volatile component will be compared to solvent. When compared to solvent, if the solute is more volatile, then it gives more vapor pressure. So vapor pressure will be increased. So this is some important thing. Non-volatile solute decrease vapor pressure, volatile component increase vapor pressure, temperature increases, nature of liquid. Then another thing is regarding which one? Very important thing is boiling point. BP. Boiling point Liquid, you know, liquid boils at particular temperature. When we are heating the liquid, then liquid molecule starts, the water drops from the bottom of the liquid will starts movement and come to the top. Then regular movement of bottom molecule towards top, then top molecule towards bottom, it will be continuously randomly move. That is called a boiling point. During boiling point, the liquid boils. That it requires some temperature. But boiling point and vapor pressure, both case is inversely. Remember, vapor pressure is inversely proportional to boiling point. Very important. High boiling point of liquid, low vapor pressure. If liquid has higher boiling point, then vapor pressure is low. Higher boiling point means more temperature required to break intermolecular force. If intermolecular force is high, then automatically vapor pressure is low. Already we discussed here. High intermolecular force, low vapor pressure. Vapor pressure is inverse proportional intermolecular force. So high boiling point, low vapor pressure. Low boiling point, high vapor pressure. You know, spirit, for example, spirit. Spirit has higher vapor pressure than water. Vapor pressure is high. This is vapor pressure. This is compared to vapor pressure. But oppositely, water, but this spirit has lower vapor pressure than water, lower boiling point than water. So spirit has higher vapor pressure than water, but if you take the boiling point, spirit has a lower boiling point than water. So vapor pressure and boiling point is inversely. But when we measure the boiling point is measured the liquid when the vapor pressure of liquid is equal to external pressure. Means external pressure means that is atmospheric pressure. Atmospheric pressure. When atmospheric pressure will be equal to vapor pressure, that is called your boiling point. The temperature at which the vapor pressure of liquid equal to external pressure. When you heat the liquid, then vapor pressure is going on increasing. When it will equal to external pressure, then liquid starts boiling. So liquid boiling point depends upon vapor pressure. For example, we can take this thing, very important thing. Boiling point of liquid, generally boiling point will be low. Boiling point will be low at high altitude. At higher altitude. At higher altitude, boiling point is low because vapor pressure, that atmospheric pressure is low. Low boiling point will be low at higher altitude because if you go up, then the atmospheric pressure is low. If low atmospheric pressure at a lower temperature, liquid boils. Boiling point of liquid in the pressure cooker is more. Why the boiling point of liquid in the pressure cooker is more? Because the pressure cooker is closed. As it is closed, the vapor inside the liquid has high. If vapor pressure is automatically, as the pressure, when the pressure increases, automatically what happens? Temperature will be increased. Already you know the gaseous state condition, if the temperature increases, then automatically the boiling point that means the pressure will be more, means temperature will be more. That is a relation. If pressure is high, automatically temperature will be high because the container is fixed, volume is fixed. We cannot change the volume of the pressure cooker. But when the vapor of the liquid is kept in the same pressure cooker, when we increase the temperature, what happens? The pressure will be more. When the pressure is more, automatically temperature will be more. That's why boiling point of liquid increases inside the pressure cooker. If you boil the water in open vessel, let it be 1 atmosphere pressure, the boiling point is 100 degrees Celsius. But if the same liquid will be boiled inside the pressure cooker, it may be more than 100, 101, 102 like this. So boiling point increases inside the pressure cooker means while we are covering, when we are preparing your rice or cook any vegetables, when we are preparing, we are covering the lid of the container, because when you cover the lid of the container, the boiling point of water inside the container will be more. That's why it takes very low time, less time to cook your food. So that's why vapor boiling point of liquid increases inside the pressure cooker due to high pressure. Then liquid can boil at vacuum. Boiling point of liquid decreases in vacuum. Means if you keep the whole container in vacuum, that is no air. If air will be evaporated from the container, if you start boiling of the liquid, then what happens? The boiling point will be low. Liquid can boil at higher temperature, liquid can boil at lower temperature, depends upon the pressure. If it is kept at high pressure, boiling point will be more. If it is kept at low pressure by evacuation, by vacuum, in vacuum means there is no air. That's why vapor pressure of liquid will be decreased. Water can be boiled at 70 degrees Celsius. Water can boil at 110 degrees Celsius. That means it depends upon the what? Pressure. That means if pressure is more, if air pressure is more inside the container, then boiling point will be more. If air pressure inside the container is low, then boiling point will be low. So then another very important point is, like if you add salt, volatile, non-volatile solute, non-volatile solute increases the boiling point of liquid. When you add salty water, higher boiling point than water. But here, already discussed that what? Salty water has a lower vapor pressure. Salt water has a lower vapor pressure than water, but salt water has higher boiling point water, because boiling point and vapor pressure is inversely. Higher boiling point, low vapor pressure. Just opposite. If liquid has a higher boiling point, its vapor pressure is low. So salty water has higher boiling point than water. That means sea water boils at higher temperature than river water, well water, your pure water, distilled water. Salty water has higher boiling point, but salty water has lower vapor pressure. So these are very important that characteristic of liquid. Okay, so liquid has very important characteristic that it has a particular vapor pressure at constant temperature. Every liquid has vapor pressure. Liquid evaporates at all temperature. Evaporation takes place at all temperature. At every temperature, evaporation takes place. But evaporation can be faster at higher temperature. So, vapor pressure, liquid has vapor pressure will be measured only at the equilibrium state. When vapor and liquid will be equilibrium, at this stage, when you measure the pressure by using manometer, that pressure is called vapor pressure of liquid. And vapor pressure of liquid can be affected by different conditions, nature of liquid, temperature, external substance, that is non-volatile, volatile solid, and with temperature. This is the graph, vapor pressure and temperature. Vapor pressure and boiling point just opposite. Liquid has boiling point, liquid has a vapor pressure. But if liquid has higher vapor pressure, boiling point is low. This is the condition already discussed. So that's a boiling point can be increased, decreased. Boiling point can be decreased if the pressure is low. If you go to Everest, then the same liquid boils at lower temperature. But if same liquid you boils at the coastal belt, at the sea belt, then the boiling point will be more. So the boiling point of liquid can be changed with atmospheric pressure. Low atmospheric pressure, low boiling point. High atmospheric pressure, high boiling point. That's why boiling point liquid inside the pressure cooker is more. That's why it takes less time to cook the food. But why you are boiling, why you are adding salt during boiling of egg? That is not for tasting. We are adding salt to normal egg during boiling. Why? Because when you add salt to water, the boiling point of water, the temperature water will be more by adding salt. When temperature will be more, then egg can be easily boiled. Very less time, with a low time, the egg can be boiled because temperature of water is more. Because we have added salty water. Salt water has higher boiling point. So temperature water, if you add salt, will be more. That's why it takes less time to boil. This is the very important condition. But when liquid evaporates, when liquid automatically evaporates in an open vessel, then it causes cooling. Evaporation causes cooling. When liquid converts to vapors, then the temperature of the liquid decreases without heating. If normally the water or the liquid will be kept in open vessel, then temperature of the liquid goes down because the energy, the liquid average energy decreases because the liquid molecules convert to vapors. So automatically the average kinetic energy of liquid decreases. When liquid molecule convert to vapors means the average energy of liquid molecule decreases. That's why temperature decreases. So that's why evaporation causes cooling. But when we heat the liquid, temperature increases. That is different thing. But at room temperature, when the liquid evaporates automatically, at room temperature, when evaporation takes place, then the temperature of liquid, what happens? Decreases. So these are some important application of vapor pressure, boiling point of liquid. So you practice more. Next class we discuss about the surface tension and viscosity of liquid. These are another two characteristics of liquid. Okay, thank you all.